standing in my parking lot. So you would have guessed the topic, to cherish. So we are going to cherish on liquid fuels. So these vehicles here can move only if it is fed with petrol or diesel. So petroleum or crude oil, it is naturally occurring fuel which is a mixture of hydrocarbons. So the word petroleum comes from the Latin word where petro means rock and oleum means oil. So today we will also see the different unique properties of liquid fuels like pour point, flash point. Okay, and the next part is classification of liquid fuels. So it is classified into primary and secondary. So we will see the various classifications. And the third part is the theories for the formation of petroleum. How this petrol has formed, and based on that we have three theories: metal carbide theory, Engler's theory and modern theory. Modern theory is more acceptable. So the conditions and the formation is more acceptable in modern theory. And the last part, the very important part, is about the fractional distillation of petroleum. How we can segregate the various fragments of petroleum by fractional distillation, that is heating at various boiling points of the fractions. Okay, so and the applications of those fractions. So we have a lot to study. So shall we go to the slideshow?
Hi students, such a joy to meet you all after a long time. Today we are going to cherish on the topic liquid fuels. Under liquid fuels, we are going to see the unique properties of liquid fuels and the classification and how liquid fuels are different from solid fuels, the various theories for the formation of petroleum, now how this petrol is formed long ago, and then we are going to look into the fractions that is obtained from petroleum or crude oil by fractional distillation method and the applications of the various fractions. So shall we proceed and shall we go to the journey of liquid fuels? Yeah, so as I told you, this liquid fuels are combustible or energy generating molecules. Okay, so we get a lot of energy from liquid fuels, and mainly if you see most of our vehicles, they run with the help of liquid fuels. So it is helping to create mechanical energy, or in other words it generates kinetic energy. Okay, and they take the shape of the container, and these are some properties of liquid fuels: density, viscosity, flash point, pour point. So what is flash point? It is the lowest temperature at which a fuel can be heated, and pour point is lowest temperature at which the fuel will flow. Calorific value is, we all know that it's a very important property for a fuel, the heat that is produced. Specific gravity and sulfur content, ash content, carbon residue, water content. So these are some properties of fuels. And the next category is the classification. Again, liquid fuels are also classified as natural and synthetic, and natural is further classified into primary and secondary fuel. And if you see basically the meaning of petroleum is the mineral oil, or it is obtained, the oil that is obtained from rock, where petra means rock and oleum means oil. Okay, so it's a mineral oil, otherwise known as crude oil. It is a viscous liquid which contains hydrocarbons and also small amounts of non-hydrocarbons, and we can obtain it at a depth of around 500 to 1500 feet at various places. So it's mainly composed of straight chain paraffins, cycloparaffins, naphthalene, olefins and aromatics. And if you see the difference, the coal is mainly formed from land plants, whereas petroleum is formed mainly from sea plants. And the second difference is like wherever you find the debris of coal, there itself you find the deposits, or you can extract coal from the same place, whereas petroleum, there is a migration from the accumulation of debris. Okay, And composition, very important, is it consists of hydrocarbon, and hydrocarbon is in the form of paraffins, naphthenes, aromatics and olefins. You have sulfur compounds and you have oxygen and also you have nitrogen compounds. So mainly you have carbon around 84%, hydrogen 11%, sulfur, nitrogen, oxygen the remaining percentage. And how do you obtain it? There are a lot of methods, either geophysical methods or geological methods or by drilling. So these are some ways by which we can detect the deposits of petroleum. And as I told you, theories. Now there are a lot of interesting theories now this predicting how this petrol would have originated. Number one is carbide theory, where they say that hydrocarbons present in petroleum are formed by the action of water and inorganic carbide. Okay, so water and inorganic carbide. So if you can see here, the first step is formation of inorganic carbide, and the next step is inorganic carbide reacting with water and then undergoing hydrogenation, then polymerization. So once you have formed a hydrocarbon and then the hydrocarbon polymerizes. So this is the ideology of carbide theory. And the second one is Engler's theory, where they say that the petroleum is of animal origin and it is formed by the decay and decomposition of marine animals under high pressure and temperature. So that's the theory of Engler. And experimental support evidences is also obtained, because you can see the presence of seawater, presence of nitrogen and sulfur compounds, presence of optically active compounds. So all this are experimentally proven. Only thing is you couldn't prove the presence of chlorophyll in petroleum, and also it does not explain the presence of coal deposit near to the oil fields. So these are all some failures. So the next they went on to modern theory, which is mostly acceptable. So it is of it says that petroleum is of animal as well as plant origin, and it is formed by the decay and decomposition of marine animals as well as plants of prehistoric age. So and this would have been formed because of earthquakes. Marine animals got buried under the crust of earth and high pressure and temperature under the earth crust for long period of time, and subsequently decomposition would have taken place, finally forming petroleum. Okay, and this explains the presence of nitrogen and sulfur compounds and even the presence of chlorophyll and optically active compounds. So all those failures that was found in the previous theory was explained in modern theory. And as I told you, classification of petroleum depending upon the nature of hydrocarbon, what hydrocarbon is present. There are 4 different forms of hydrocarbon: paraffinic, naphthenic, asphaltic, or all the 3 mixed together. And composition, typically carbon is higher, hydrogen is the next rank, then followed by nitrogen, sulfur and oxygen. Okay, so these are the constituents present in petrol, and these are called as the fractions. How do we segregate these constituents, or how do we obtain this fraction? By a process called fractional distillation. A very, very simple process that all of us are aware of, separating of a mixture on the basis of their boiling points. And how do you separate it? By applying heat. As you heat it at various boiling points, now each fragment will be segregated at a particular boiling point. So the vapors of a boiling point will separate at a particular temperature. So and therefore you can segregate it. So very simple and a very known process. Okay, and this is done using a distillation column. See, this is what it is. Okay, so this is you have a lot of substances, gases, gasoline, aviation fuel, heating oil, diesel oil, naphtha. Okay, and here again, how do you get all these things from? Where do you get all these things from? From crude oil. And what is crude oil? Again, it is also a fossil fuel, and just the petroleum. The other word, the typical word is crude oil. So just like coal, no, you call here as crude oil. It is a mixture of hundreds of different compounds, and from that we segregate into different constituents of fractions, and that is our various liquid fuels. And yeah, so crude oil is used to make fuels. As such, crude oil is used to make fuels for transportation, heating, generating electricity, and also for making plastics and various chemicals. And yeah, here we have a brief history of crude oil. Actually, no, only after the internal combustion engine and gasoline, then the interest towards crude oil also started. And it was gasoline was a byproduct in kerosene production, and this led to a great increase in the demand for crude oil. And till now, we are back of crude oil. The whole the country's the whole world is in need of crude oil. And yeah, finding crude oil at sea, earlier I said about geophysical method, geological method. So crude oil is often found trapped in rocks of the seabed, and you use oil rigs or drilling platforms to obtain the crude oil in the seabed. And yeah, so this crude oil as such is not usable. You have to convert it into fractions. So, and how do you convert it? Based on the boiling point. So generally, larger the hydrocarbon, higher is its boiling point. This is again because of the intermolecular forces between large molecules are stronger than the intermolecular forces between small molecules. Okay, so larger a hydrocarbon, higher is its boiling point. Okay. So, and again, how do you segregate it? By fractional distillation, which is a process used to separate mixture of liquids that have different boiling points. And this fractional distillation is used to separate crude oil into fractions under various boiling points. Okay. See, liquids with a higher boiling point remain as liquid, and liquids with a low boiling point evaporates and turns to vapor. And the vapor can be further separated into liquid. See this picture, I think it will very beautifully explain what happens. Breaking down of the mixture into various components or various fractions on heating. So simple thing what we are doing is heating. Okay, but only thing at different temperature. Okay, so at different temperature you obtain different fragments. Again, you can segregate it as heavy fractions and lighter fractions. Heavy fractions have high boiling point and they condense near the bottom of the column, and lighter fractions have a lower boiling point and they condense, they go at the top of the column here. Yeah, see, this will give you at various temperature what are the fragments that are obtained and what is the application of those fragment of fractions. Here you can see LPG at what temperature, and petrol or gasoline at 120 degree, and paraffin oil at 170 degree, and diesel oil. Okay, so if various fractions, and everything is having a unique property and everything is used for a different purpose. Yeah, here this chart will tell you about the exact temperature at which petrol is obtained, naphtha is obtained, kerosene is obtained, diesel oil at 250, and everything they have a different application. Kerosene is used as a gas for heater, diesel oil as a vehicle for vehicles, lubricating oil, they reduce friction between multiple parts, fuel oil which is used in ships and power station, greases and waxes, bitumen for road, tar and roofing. Okay, so these are the various fractions that is obtained from crude oil at different boiling temperature, and every fraction has a particular use and it is used in various other areas, and that is how we are running. Fine. So with this we will stop, and apart from this you have a lot of other things to see. So once we obtain the fragments, there are other process called cracking. So maybe we can see it in the next video. Okay, so we'll stop here. Thank you so much for listening. Thank you.